We do not, you all, okay, you don't have to be network geniuses after week one, not even by the end, right? We just want to keep getting better and better and better and better. And I'm glad you said something about like when you're looking at packet sniffers or things, like you're going to be looking at hex values and MAC addresses, which are in hex. So like this stuff, whatever job you end up in, chances are you're going to deal with binary and hex. So if you get, comfortable with it now, you'll be able to get good at it when you're in your job function, or you'll continue to just get good at it as you move through these classes. Hopefully you'll go into the other Cisco classes like 150 and 160, but even if you don't, if you go into Linux, you're going to see hex, you're going to see binary. If you are going to take a programming class, you're very likely going to see hex. You're going to have Boolean and stuff like that you're going to have to deal with. Guillermo. What's that?
It's not letting me sign in at all.
Oh, it's not letting you sign in.
Yeah, I tried it regularly, then I tried at Maricopa, then I tried at MQC Dom.
So when you just used your MEID, it didn't work? Yeah. Password. Oh, I can see why. Okay, hold tight for just a second. Okay, can I get everyone's attention for a minute? Because this is something that could happen to you, what's happening to Guillermo right now. Because sometimes if you look here, and because we haven't addressed this yet, if you look in front of your computers, you're going to see some jacks and some Ethernet ports. Your computer should be plugged into the black jack. If it's plugged into the red jack, your computer won't work right. So if you come in and that happens, look and see if maybe the last student didn't move that over. And so I'll take this as an opportunity that when we start moving into labs, it's really important that you move the jacks, the Ethernet cable back into the black jack. Although right now all we have are computer classes in here, sometimes we share this classroom with like English students or nutrition students. And when they come in and the computers don't work, like they don't know how to fix it at all. So we need to be really good at always moving our cables where they belong, okay? Okay, happy to see everybody. We're going to do some review. The first thing we're going to do is Boolean. A 1 and a 1? 1. A 0 and a 1?
0.
And how about a 0 and a 0? 0. Okay, so we're going to do a little bit of Boolean practice, and then we're going to do some binary basics, and then we're going to do some binary decimal to binary, just get our brain back in the game, and then we're going to learn some new stuff. Do I have everybody in here? Let's see, I think so. Or am I missing somebody? 4, 8, 9, 10, 11, 12. I'm missing a couple people. Thank you. Who else? 2 more. Thank you. Right. So if you need to write these out on one on top of the other, that might help. It makes it a little bit easier because it's just going to show it in line. Nicely done. This one's a little harder. You're doing all 8. 8 bits in a row is called an octet. Chase, can you put dates on those activities for today? Start with that very first one, the Boolean one, and publish it, the Boolean one. Nicely done. Okay, everyone feel pretty good about Boolean? Okay, nicely done, Ozzy. Perfect, good job, Joey. Coy. Who's Coy? Oh, good job. Oh, is that your last name?
Yeah.
Oh, okay. Let's see. Any runners-ups? Not giving us the runners-up today. Okay, so we're going to do another one. Let me pull it up. I'm going to review a little binary basics. How many bits in an IPv4 address? 32. How about in an IPv6? 128. How many octets in an IPv4 address?
4.
How many bits in a byte? 8. Okay. Ooh. And we did positional values, right? Do we need to review them? Let's see. Okay, let's do a quick review of the positional values. First of all, what do positional values do? They repeat in every octet. It's not enough to just say they repeat. I'm like, well, what are they? Repeat in every octet, okay? All right, so first of all, we have 8 of them, right? Let's start with the biggest one. What is it? 128. Next. 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 Okay, so there's our positional values, right? Let's see. So what if I have this? What would our number be? Okay. And how about if I have the same thing, but I turn this one on? Okay. Right. All right. Excellent. 8 bits in an octet. Slow is fast. I can always tell when it's just like you did it too fast. How many? 32. 32. Binary counts in a base of 2, right? By 2, 0 and 1. Chase, are you doing the brain teasers too? Yeah, go ahead and do those brain teasers. And then do the 3 under the subnet masks as well.
Okay.
Yes. 8. Yes. Last one. 8, 8. So what do we got? Good job. Daniel, nicely done. Okay, so Jason, Daniel, and Matthew, excellent. Gabby, nicely done. Marcus, good follow-up on there. And, you know, again, this is, with Kahoot, it's like how fast you do it and the number that you get right. So even if your name doesn't show up on there, that doesn't mean anything to me, right? I know that you might have got them all right and did it slow. And in this game, sometimes fast is slow is fast, right? Because if you're rushing through stuff, you might make mistakes, especially when we start doing labs. So it's better sometimes to take your time. You know, these are super fun, but again, don't think anything of it if you're not showing up on the board, you know, week after week. It's cool when you do, but I know that you're, you know, possibly still doing really good on these. So, all right, so let's see. These are published. So if you go, I'm in modules. So we're still in week 1, right? This was Tuesday's class activities, and now we're at week 1, Thursday's class activities. And we just did this Kahoot Boolean, and we did the Kahoot binary practice or binary basics. You can find it in modules. You could probably find it on your to-do list. And you can click the wheel, and it will open up. And what you're going to do is you're going to take the quiz, and you're going to let us know that you did that in class. We'll verify it later. Same goes with the binary basics. You're going to let us know that you did that in class. And submit that. Got it? Perfect. All right, so everybody, I want to take a look at our IP address, our own on our device. So can somebody tell me again, like where can I find my own IP address?
Windows key, CMD, then IP config.
Yeah, on the Windows key. So let's go to the Windows key. So that's this guy right down here. You can click on that. And then you can actually just start typing either command or CMD, and it will bring up the command prompt. Okay, and it's going to look like this. All right. And then there's a Windows command that I can use. What is it? Yeah, ipconfig. Okay. And so today we're going to start talking about the subnet mask. And again, I want to just remind you and ask you, like, we're going to be learning things, and it'll be like, why are we learning this? It'll start to come together next week, why we're learning it. But we have to kind of get through some of the early phases to get to the stuff that'll start to make it make sense, okay? All right, so I have an IPv4 address, which is 10.204.68.96. And then I can also see my subnet mask. So what I'd like you all to do is write down your IPv4 address. Okay, so we're going to write it down. And then I want you to go ahead and figure out what it is in binary. Okay, so like the 10, we're going to start with that. Now, our IPv4 addresses are probably very similar until we get to the last numbers. Okay, so let's see, how do I bit out the number 10? So if I've got my positional value of 128, 64, 32, 16, 8, 4, 2, 1, is the 128 turned on? Nope. How about the 64 and the 32? 16? Nope. 8? Yep. 4, 2, and 1. Okay, so that's how I bit out 1, 0, 1, 0. Okay, so I want you to go ahead and bit out your IPv4 address. Okay, bit out your IPv4 address. You can do it on a piece of paper, you could do it on the notepad, do it in your mind map, wherever you want. When you think you've got it, just pop your hand up so I can see where we're at. Okay, thank you. Thank you. And if you get stuck, don't worry, we'll do it together. It's a big hunk of brick right there. What the heck? Like, got it? Perfect. Oh, it's powering your shoes. Now I understand. I'm joking. I know. Got it? Perfect. Got it? Okay. All right, so let's see. So in my first octet, I've got the number 10. Does everybody raise your hand if yours is 10 too? Okay. What about the 204? Okay, so let's do 204. All right, let's do 204. Okay, so if we're doing 204, do I need to turn on the 128? That's a yes, right? And then let's see. So 128 plus 64 is 192. So do I have to turn on the 64? I do, right? So now we're at 192, but I'm trying to get up to 204. So what about the 32? Do I turn that on? No, that one's off. That one's off. Okay, so then 128 plus 64 plus 16? Nope, okay. So then 192 plus 8, that takes me to 200. So do I have to turn that one on? I got that one turned on. So we're at 200, but I still need 4 bits. So the 4? Yep. And what about the 2 and the 1? 0. Okay, so now I'm going to just bring it down here. 1, 1, 0, 0. Okay, and then let's see, 68. Does everyone have 68? We all have 68 too, okay. So you're noticing that we all have a few numbers in common. Okay, that's the network. That's because we're all on the same network, local area network. Okay, so we're going to start using these kinds of terms. Okay, so can someone raise their hand and give me the 68? Caesar. 0, 1. So we're at 64.
Yeah, 0, 0.
So we're at 64. So let's see, 128, 64, 32, 16, 8, 4. We're at the fourth positional value. 1, because 68 plus 4, right?
Sorry.
Then 0, 0. Okay. Now, if I know networking, and I do, we should all have a different number here. So I have a 96 because, again, we all have to have a unique number because no IPv4 address on the same local area network can be the same. So we all have to have something different when it comes to the actual host address. So these are called a host. So each host has to have its own unique address, but we all belong to the same network. Okay, we all belong to the same local area network. So for mine, it's 96, 0, 1, 1, 0, 0, 0, 0, 0. Okay, so let's see. Kevin, what have you got?
1, 0, 1,
1, 0, 1, 0. 0, 0, 0, 0. So 160. What is your last number?
170.
Oh, so then it's got to be this. That's nice because you have two easy patterns. You have the easy pattern of 160 and the easy pattern of 10, right? 160 plus 10, 170. Marcus, what have you got?
0, 0.
0, 0.
1, 0.
1, 0.
1, 1,
1,
1.
1, 1.
0.
0. So what is that one? 46. Okay. Orgel, what have you got?
I got 0, 0, 1, 1, 1, 0, 1, 0.
Okay. So what have you got? 58. Perfect. Okay. So see how that goes? How about yours, Matthew? What do you got?
0, 0, 1, 0.
0, 0, 1, 0. 0, 1, 1, 1. So what have you got? 39. Okay, we all good? Perfect. Okay, so here's the next thing that I want to talk about and what we're going to talk about today. And I see a lot of you have already watched the video, so thank you very much. We're going to talk about the subnet mask. Okay, we're going to talk about the subnet mask. Now, first of all, the subnet mask, from the format, it looks a lot like an IPv4 address, okay? So formatting-wise, it looks the same. It's not the same, though. It's really not the same. So one way, if you could think of the subnet mask as it's like an indicator. It indicates or it tells the host what network it belongs to. And it lets the host know which one of these bits is part of the network. Okay, so it's an indicator. It's an indicator. But we come up with it as far as binary in the same way. Okay, so right here, if I have 255, what does that look like in binary? Yeah, just everything is on, right? And then again, notice there's still 4 octets, just like our IPv4 address, right? So it's all on. So what I want us to start doing is thinking about how the subnet mask aligns with our IPv4 address. So what I'm going to do is I'm going to take my subnet mask and I'm going to just line it up right underneath my IPv4 address with my octets. Now, we should all have the same subnet mask, okay, because we all belong to the same what?
LAN.
Yeah, the same LAN, the same local area network, okay? And then what about my octet for my subnet mask, the second one?
It'll be the same as the first.
Yeah, it's going to be the same as the first one, right? So again, I'm going to just kind of line that right up under here so that I can see exactly what's going on. Now, the third octet in my subnet mask is 254. So that's going to be 1 bit different. Exactly. My first 7 are on, right? So there we go. And then my last octet in my subnet mask is all what?
0.
Yeah, it's all zeros. Now, what do you notice about, so we can see that it's got the same format in terms of the octets, right? But what do you notice that's different about the ones and the zeros? Okay, they're split. And tell me, explain that a little bit more.
Like there's no, it's all ones or it's all zeros.
It
It doesn't go
Yeah,
back and forth.
exactly. It's all ones in a row followed by all the zeros in a row. And again, that's because it's not an IPv4 address, okay? It's like an indicator. So what I would like to do, so everybody go ahead and get your subnet mask underneath your IPv4 address. Okay. And then what I want you to do is, in your subnet mask, find the very last one in your subnet mask, which is in our third octet. And I want you to just draw a line after that one. I want you to draw a line after that one. Okay. Now the subnet mask tells us all kinds of things. Okay, so first of all, what do the ones represent in a subnet mask? What are they representing?
The classification of the subnet mask?
Can you give me a more general answer?
No.
Okay,
Sorry.
Jason?
It identifies the bits which are the network portion of the address.
Exactly. So the ones in your subnet mask represent network bits. Okay, so write that down. Ones represent network bits. So if we were to all put our information up here, we would see that all of us have these same bits in common in our network. So if you look at your network, if you look at your IPv4 address, you'll see that where the line is, all of these match. Mine, Marcus's, Joey's, everyone's is going to be the same. And why is that? Because we're on the same LAN. We're on the same local area network. Okay, we're on the same local area network. Now, over here, all of these zeros, what do they represent? Hosts. So these are the different kinds of hosts. And remember I said each of these are hosts, right? And all the host addresses or numbers have to be what? Unique. They all have to be different. They all have to be unique. We can't have the same one. Again, if you can kind of think of it like a cell phone number, we can't have the same cell phone number, right? I mean, even if what makes it different is the area code, right? So, but we can't have the same mobile phone number. It's the same with an IPv4 address. We can't have the same one, okay? So, everything over here are network bits, and everything where the zeros are host bits, okay? Now, network bits, they don't really change. If we're on the same network, that's it. We're on the same network. So in the video, like I kind of compared it to like a zip code, right? So like if I live in a certain zip code, if I live in 85032, my next door neighbor lives in 85032, although there is a divider at some point, right? But we have that same thing in common, right? But again, we have a unique address. We have a unique address. And then, but these, everything over here on the hosts, these can be changed, okay? And what the computer does, or the addressing protocol that's in effect, is it flip-flops these bits to make everything unique, okay? So like the computer and or the DHCP protocol, it's just flip-flopping these to make sure everyone has a unique address. These can't be flip-flopped. These network bits, they don't get flip-flopped. But here, they can be flip-flopped and changed in all different ways so that everybody gets a unique address. Does that make sense? Okay. So the way that we see the subnet mask in decimal is just like we do with the IPv4 address, 255.255.254.0. But because of the way that a subnet mask is formatted with all ones followed by all zeros, there's like a shortcut or an abbreviated way to represent the subnet mask. What is that called? Not exactly. I think you're thinking of variable length subnet masking. So say it again. Slash notation. Yeah, or the prefix length. So Gabby, can you explain what slash notation is? Exactly right. It's just counting the ones, right? It's just counting the ones. Because it's just a short way to write the subnet mask. So let's just count up these ones, okay? So the first octet, how many ones do I have? Okay, plus another. So I'm at what? I'm at 16. And then I've got 17, 23. Okay, so I could write my address like this. 10.204.68.96 slash what? 23. Okay? It's just a short way of writing the IPv4 address with your subnet mask. Okay? Now, I want to make sure that we get a good habit started. Whenever we're doing an assignment that requires you to outline your IPv4 address in a lab or an assignment or a description, always include either the subnet mask or the prefix length. Okay, because if you just write, 192.168.0.27, can I tell what network that belongs to? It is a private. I know that it's private, but can I tell, is it a /24? Is it a /19? Is it a 255, 255, 252? Like, I can't tell. So it's important that you always include whatever the prefix length is for that IPv4 address, okay? Now, you could also write out the full subnet mask, whatever that is. But if it's missing, I'm like, well, who knows what network that IP belongs to? Okay, so it's important that you get into a good habit of always doing that. Yes?
What's the proper etiquette for doing that? Do you do a space after your IP?
All together. Oh, yes. So let me think. How do I do it? No, just all together. Sorry, I can do it when I'm typing, right? Just run it all together. Okay, and usually in the assignments, it'll give you an example of how to do it. Okay. Now, sometimes an assignment will specifically say use the prefix length, which is the slash notation, or it'll say use slash notation, or it'll say write out the subnet mask. So just read the directions and, whatever it tells you to do. It doesn't usually ask for both. So if it says subnet mask, it doesn't need the prefix length. If it says prefix length, it doesn't need the subnet mask. And you're going to get assignments that ask for it in different ways because who knows how you're going to be doing it wherever you end up at. Okay, so I just want you to be able to get in the habit and the practice of seeing it and knowing it in both ways. All right, make sense? Okay, so let's see here. Chase, are you still in the class?
Yeah.
Can you do the next two, the convert, or did you already do them? Oh, can you do the binary to decimal and the decimal, the binary brain teasers?
Those already open?
You've already got them open. Okay, perfect. Let me refresh my screen. Okay. Look at the octets. Can you unpublish the octets and the subnet increment?
Yes.
Thank you. Okay, so let's do these brain teasers. The convert binary to decimal and convert decimal to binary. Let's we're going to go in there and we're going to take this quiz. And it's just going to be practice, okay? So here we're going to convert the 1,001,000 to the decimal. So just do those. There's 2 of them. If you don't get every single one of them right the first time, you can do it a second time. Okay, and then, so let's everyone try to get through both of them at least once. And if you miss a couple, you can go back later and fix them, okay? But let's make sure we're all we're kind of got a good grasp of the binary to decimal and decimal to binary. if you want me to take a look at anything, just pop your hand up and I'll take a look at it. Also, you know, if you ever find a mistake in the answer, like if it marks you wrong and you think you got it right, just message me. Sometimes the answer key's wrong and you might be right, and then I can fix the answer key, give you the point. So if that does happen, just know that we'll fix it, you know, and it happens sometimes. Got a lot of moving parts in here, so, you know. And if you want me to look at something, just pop your hand up, I'll come look at it. So just get through both of them at least once. If you've missed a few and you want to redo it, you'll have a chance to redo it. All right. Okay, so I want to talk a little bit about some assignments that you're going to be seeing over the weekend and just talk you through some of them. So everything that we've been doing today and Tuesday were videos that were due this week, right? And so there's a lot of videos due next week. And so it's going to put everything that we did this week together. Like, why did we need to learn how to convert binary to decimal, decimal to binary? Why do we need to know how to do the subnet masks? We need those things to do network addressing, okay? And then notice here the host and the magic number. A lot of this will be review for you. So, and then the network address ranges and VLSM. So I want to talk about this. So see how this says 26 minutes? I don't remember exactly, but the way I think I remember it is I've recorded it, and then it says, if you've got this, you can stop now. But then I keep giving like another example and another example. So you don't necessarily have to watch all 26 minutes of it unless you're like, okay, I got to do one more. I got to watch her do one more. Okay, so I know that a lot of these look long, and you may not need to watch them that whole time, or maybe you do, right? It's whatever. So I just want you to be aware of the way those are kind of laid out. Like a lot of times I'll say, keep watching if you want another example. Stop here and keep, or keep watching. So just keep that in mind. And I might have already said this, but I'm going to say it again. This kind of stuff, like you might leave here and totally have it. Like, oh, this is great. I'm so good at binary to decimal and decimal to binary, and I totally understand how to do a network address. And when we get to VLSM, like, oh man, I got this. And then like Saturday, you sit down to do some VLSM problems or some network addressing problems, and you're like, did we do this in class? I don't even remember this. I thought I could do this, and now I can't do this. All of that's really normal. And so when and if that happens, I'm not saying it will, but it happened to me when I was learning it. I'd be like, man, I could do this in class with no problem, right? It took me a lot of practice. So what I don't want is I don't want you to just be beating yourself up or be stressing out over the weekend. I want you to keep plugging away at it, but if like you get stuck, just step away from it and then come back to it. Maybe you have to go back and rewatch the video. Maybe you have to look at something. That's all that. It's normal. I just really want you to know that's totally normal. And again, if you get it right off the bat, that's cool too. Okay, I don't want you to think you're going to have trouble. It runs the gamut. It's the whole spectrum. Okay. Also, over the weekend, this is. If you didn't already, I want you to make sure you have my cell phone number, the 909-475-7809. It's in the syllabus, and I'll rewrite it. If you get stuck on an assignment or stuck on something, or you're not sure what I want you to turn in, or it seems like there's something not working, just text me. I don't want the first couple weeks to be a holdup for anything, because there's I do things different than some instructors. Like, we got a lot happening in class, right? You're doing mind maps. Today we're going to talk about flashcards. I totally understand that. So I don't want anything this weekend to hold you up. So if a phone call to me or getting on a web conference or a text clears that up, just send me a text. Tell me who you are, what class, and if I'm available, I'll answer, okay? So, and same goes with if you start to see like that you turn something in a couple days late and there's a late penalty and some points have been removed, again, do not stress. I'm going to take all those, at the end of next week, I'm going to take all those late penalties off. I want you to see everything on your calendar. So I'm not going to move the dates because I want you to see them. If I start moving the dates, well then, for those of you that just look on the day of, you're already too late. Okay, you're already too late. So now at the end of next week, I'll take the late penalties off, and then then it'll be going forward, the late penalty will apply, okay? So again, I just want you to get the lay of the land, get the feel for the class, do some mind mapping, you know, and I want to talk to you about the flashcards. Just start getting in there and seeing how all this works, okay? So we already did the mind map, and I just want to walk through this again. I think we did it, but I want to just walk through it again and kind of give you the way I learn and the way I do classes when I'm doing stuff. Not that you have to do it that way. I'm just, you know, kind of giving you my process. So the assignment, again, is to read the module. And for me, I like to read and do the important objectives and the mind map all at the same time, okay? So this is telling you to do the mind map. And here are the important objectives. I don't remember, did we already talk about this? I confuse my 140 classes. I can never remember what I do in each class. So each module will have a list of questions, okay? What is the difference between a peer-to-peer network and a client-server model? You're not required to answer these questions and turn them in, but these are things that are in the module that are important to have an idea about and to understand. So when you're creating your mind maps, this would be a starting point. You know, like, do I know what a peer-to-peer network is? Do I know what a client server? Just pop it in there and create a flashcard. Like, I do it all at once. I read, I add a little bit to my mind map, and I do a little flashcard. You know, I'm not writing word for word out of the book. I'm doing like a quick question, a trigger. So the way we'll do flashcards next week is we'll come in, you'll pair up with someone, and you'll quiz each other. We'll do that for 10 minutes, okay? Maybe 15 minutes, depending upon the module, okay? Now, I do know people that they'll read the whole thing, they'll go do the mind map, and they'll create flashcards. That's okay, too. For me, that takes too long for me. I like to just kind of, whatever class I'm doing, the last class I had was a cloud class. I just sat down, I read. I was like, okay, what is that saying to me? I put things in my own words, things that my brain will understand, okay? And then I make a quiz question. What's important for me to know about this? What could I ask another student about? How can I help that? How would I help myself? How would I help someone else, okay? So just play with this and see how that goes. And so when you're in here, it will take you to the learning resources, which again is going to be a list of different things. Here's how you get to the book. Now this is a recording of me going through Module 1. So if you don't have time to read all of Module 1, maybe you watch the video. Now it's going to be the abridged version, like the Cliff Notes, right? I'm not going to dig into every important thing in Module 1, but I'll get the highlights. And then there's some other videos. So here's a video about the client-server model. Here's a video about what a converged network is. And then here's the Cisco PowerPoints. The Cisco PowerPoints are pretty text-heavy. You know, it's not the same as reading the book, but there's not a ton of pictures. But again, it's like the abbreviated version. Okay, so get your information somehow before you come into class and use that in order to create your mind maps. I want to make sure that you understand, like, my expectation isn't that you're doing all of the learning resources. That's not the goal. The goal is that you find something that works for your learning style, okay? If you have time to read the book. If you're like, okay, I'm not going to read this book. I don't care what she says. I'm never reading. Okay, I've had students like that. Watch the videos. So again, I want to make sure that when you leave here, you don't feel like, oh my God, this whole weekend I've got to watch 8 videos and read the book and review the PowerPoint. No, pick what works for you. Okay, pick what works for you. And as class goes, you'll find out if you're doing enough. If you come in here and you never can answer questions, or you're like, I'm clueless, I don't know what we're talking about, that means you're probably not doing enough from the learning resources. Like if you watch 2 little 5-minute videos, you're going to be lost. Okay, so gauge over the next couple weeks what do you need to do to be successful in this class. Okay, but and again, I might have told you this. I had a student one time who was like, man, I don't know how these students are doing it. I mean, like, I'm spending like my entire weekend with the learning resources. And I go, well, what do you mean? Like, how is that so? They were doing everything, like reading the whole book, watching every single video, going through every PowerPoint. And hey, I'm cool with that. It's okay if you want to do that, but I'm not expecting that. I'm just trying to give you enough material so you can find something that works for you to get the information, okay? And a lot of it is going to depend, like what do you want to do for a living? You know, why are you taking this class? How in depth do you need to understand this? Do you want to take the CCNA? You might need to dig in a little bit further. Do you want to go be a network administrator in the next year? You might want to dig in a little bit further. Are you just trying to get in and out of here? You might not need to go as deep, okay? So again, I'm trusting you to know yourself. Okay, you know yourself. Any questions about the learning resources and how to use that? Okay. And if you have questions about the grading, read the rubric. The rubric will tell you what we're looking for. If you want, like, if you're trying to get 100% in this class, the rubric says a knock it out of the park grade. It'll tell you what you have to do. Read it. You know, if you're okay with a B, read that. Okay, so it'll give you all that information. Any questions? Okay, so just again, no sleepless nights. Okay, I don't want anybody having a sleepless weekend because they're stressed about this class. I want you to have fun. I want you to work really hard, but I want you to have some fun. And I don't want any sleepless nights, okay? All right, so what are we doing next? We're going to do some Kahoots. Okay, so when we were talking about the magic number, what determines the magic number? Yeah, the positional value, right? And it's the last what? It's the last network bit. So there's a bunch of different ways. We can call that the last network bit. We can call that the last positional value, the magic number. Now, what that's going to be for us is the subnet increment. So you might also hear it called the subnet increment, because we're going to have to learn how to start building network addresses. And to do that, we're going to have to increment our subnetworks, okay? So you might also hear it called the subnetwork increment, all right? So we're going to do a couple of Kahoots where we're going to practice some of the skills that we just did. If I can find my Kahoots. Okay. When you leave today, if you need flashcards, I've got enough for a couple people for module for this week, and then you'll have to get some. So if you don't have any and you want a pack, I've got a pack for this time, and then you'll have to get some for the future ones, okay? I'm going to put them back here. Who am I missing? Who? Me? Who's me? Daniel? Okay. So you're converting the subnet mask to a prefix length or decimal or binary. So it'll tell you what to do. So we're just practicing, making our brain see what this is going to convert to. So you're converting the binary into the decimal subnet mask. So for this one, just to have you thinking about different ways that you can do this. So we know that what octet is this in? It's in the 4th. So I can pretty much eliminate like the lower numbered ones, right? The 16 and the 17 for sure. And then I might have to think about the 23 and the 27. 23 is in what octet? The 3rd, right? So then you can also eliminate that one. And then the 27 is in the 4th. So start thinking in terms of octets, like where's the last network bit? Like put all that stuff together. It starts to make answering these questions a little bit easier or faster. It's not that they're hard questions, it's just faster. Nicely done. What is this one called? What's it on? Octet boundary. Octet boundary, right? It's a /8. What's the other two? 16 and a 24. 16 or 24. Octet boundaries. Ooh, what happened here? Let's see. So we're in the 4th octet, right? Oh, so all of those except that one. So a 28, right? The 240, think about, we've got those first 4 bits on, okay? Ooh. So let's see. When in doubt, bid it out. So 255, 255, 255. And then, again, work with those easy patterns, right? So we've got 128, 64, 192, plus 32, 224, 240, right? 240, and then you add the 8, 248. It's just practice. Gabby, good job. Jesse, outstanding. Drum roll, please. Brody, good job. We got some runners-ups. Ozzy, Jason, good job. All right, so we're going to do another one. This one we're going to do. Okay. So now this one, we're just going to train our brain to look at the octet, okay? So you're just going to train your brain to look at the octet. So what this is going to ask you for is what octet is the significant bit in, the last network bit. So it just wants to know where is the last network bit. That's it, okay? Where's the last network bit? And you got to determine what octet it's in. Mm-hmm.
I'm waiting for you to change it up.
Good thinking, Matthew. I don't think I do it in this one, but
Before I click.
that does happen. I don't think this one, though.
Spam clicking over here.
It's on the what? Octet boundary? I very rarely am ever trying to trick you. Gabby, again, on the podium. Good job. Jesse, look at that. Both of you. Good job. Outstanding. Got some runners up. Good job. Okay, we are going to do another one. Okay, so now this one is for the subnet increment, okay, the magic number. So you got to know, look, you're looking at the last network bit and determining what the positional value it is. So you might want to have a positional value chart handy. I don't know if it gives you one. Right? So you're going to be determining that subnet increment or the magic number for this one. Oh, I'm too nice. I gave a chart. So let's see, 252, right? So So everybody see why it was 4? Okay. Again, if you miss it, just make sure you know why you missed it, because 252 is going to be 1, 28, 64, 32, 16, and 4, right? 240 plus the 12, 252, so it's the 4. So again, if you miss it, just make sure you know why you missed it. Yeah. Last one. All right. Oh, thanks for participating. There's no podium for that one. Okay, so let me publish these. So how do we feel? Pretty good about this? Okay, good, good. Let me get these published so we can go mark them. Okay, so I just published those 3 Kahoots that we did, the octets, the subnet increment, and the subnet mask. Go ahead and mark that we did those. So far tonight, you should have 1, 2, 3, 4, 5, 6, 7, 8 assignments that you've submitted. So just make sure you've got all those submitted so you're not missing anything. Got them all? Okay. right. Are there any questions on the syllabus? Ozzy, can you help pass these out? Any questions about the syllabus? Did I give you my no cheating lecture on Tuesday? Don't cheat, and if you do, be smarter than the teacher. Don't get caught. Yeah, look, your learning is up to you. I want you to learn a lot. I hope you can tell that. But I don't think you should not use the internet to help you, but I would rather you use it to make sure that you did it right versus to only do it right, right? So always chasing an A doesn't necessarily get you the knowledge that you need. So yeah, go ahead, pass up. Here's some more. So we're just going to wrap up tonight with hex, okay? Hex. And we're not going to go totally in depth with hex. We'll have another opportunity, but I at least want to get a little bit of it done. So hexadecimal, how many values do we have in hexadecimal? 16. Yeah, so 16. Like with binary, we had 2. Hexadecimal, we're going to have 16, okay? And it starts with 0, so it's going to go from 0 to what? Yeah, 0 all the way through F. So what are the numbers? 0 to 9. Sorry, yeah, I'm being confusing. So the actual number values are 0 to 9, and then we have letters, which are A through F, right? So we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. All right. So remember how we counted by binary? We don't have to learn how to count by hex. 16, 32, 48. I can, but we don't have to. Okay. Now, I want to review this because this is the stuff that we kind of already know. Okay, we've been practicing binary and it's the same. It's just that now we're just looking at 4 what are called nibbles, okay? So how do I write 0? 0, 0, 0. So we're not using 8 bits to represent it. We're just using 4 bits, okay? And we'll talk more about that. So we know this part. How about 1? Okay, and 2. Okay, 3, 4, 5, 6. Okay, so go ahead and fill out the rest. So what you're filling out is this fill in the table with the correct values, the hex values. So you're going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. You're going to put the binary value and then the decimal value. Okay, so fill out this whole first part. So sometimes it gives you the hex value and you fill in the binary. Sometimes it gives you the binary, then you fill in the hex. So you're filling in that table. When you've got that first top table done, just pop your hand up. So again, we're just converting it, right? We're converting the number 5 into binary. Now A, because we're just going to keep counting, so if the number is 9, the next value is 10. A represents 10, so we have to write 10 in binary. B is going to be 11, so we have to write that in binary. Right, so if we're looking at what the decimal, so this is hex, this is binary, and then we need the decimal. When you've got the top part done, the top table, can you just pop your hand up so that I know? Okay. Got it. Got it. Okay. So now that we have that filled out, the next table gets easier. Okay, the next table gets easier. So let's take a look at the hex value of 23. Okay, so the hex value, if we have a hex value of 23. So remember, this number 2 is a hex value, not a decimal value. Okay, it's a hex value. So if we want to figure out what this is in binary and then ultimately decimal, we're just going to look at these as two different numbers, okay? So first of all, how do I write 2 in binary? 0, 0, 1, 0. And then how do I write 3 in binary? 0, 0, 1, 1. Okay, so now I have 8 bits. And doesn't that look familiar, like what we've been doing? Okay, so now in order to figure out the decimal, to see if this is a hex value of 23, and I want to know, well, what is that in the decimal value? Well, I look at this whole 8 bits. And so now, what is this positional value? Well, look at it now as one single 8-bit value to get the decimal, because now we want the decimal. So 32 plus 2 plus 1 is 35. Okay, so if we know the hex and we convert it to binary, we can figure out the decimal. All right, so let's do 4b. Okay, let's do 4b. So I can see what 4 is, right? So I'm going to separate these. So 0, 1, 0, 0. I can come down here and look at b. I know that b represents 11, but it's 1, 0, 1, 1. So I'm going to write that out, 1, 0, 1, 1. Now to figure out the decimal, I'm going to look at all 8 bits, just like we've been doing. Okay, we've been looking at 8 bits to figure out our value. So I have 64 plus 8, right? So 72 plus 2, 74 plus 1, so 75. Does everybody see that? So just go slow. Okay, there's a video on it too, but break them down, right? So you got to break down the hex values so that you get the binary into 8 bits and then figure out the decimal, okay? So I just want you to work on this until the end of class. Bring it back on Tuesday completed, the front and the back, okay? And then next week, we're going to start learning how to do network addressing, okay? So we're going to build on everything we did. So finish that up, bring it back. If you need flashcards, I've got a little piled out there at the end of the desks.